Problem is that you had 10 or 12 years ago, it hasn't gone away. People have just ignored it. You people in the back, if you want to move up, come on up, and maybe it's a little easier to see. The real problem with water is people. All right, we're the only ones using it, pulling it out of the ground. All right, obviously nobody else can do it unless they have a pump, and I don't know many other animals that can do that. Turns out that I use the word future. For some counties, the future is now. All right. The presentation I'm going to give you today is based on a talk that I gave in Calvert County, because your problems here are closely related to Calvert County. I gave a speech in Charles County, and by 2040, Charles County must start looking for alternate sources of water. Their groundwater will not supply the county needs in 2040. So if you take a look at the western counties, which has a different geology and a different operation of the aquifers, many of the counties out there have promised more water than they can supply, all right, to their population. Frederick County, Washington County, and Carroll County had to have special legislation passed that created the equivalent of the transfer of development rights. It really created the transfer of water rights within the county, so that the public water supply could be guaranteed. In other words, they would have to go out and find areas of the county where they could basically buy the water rights to supply future development. The presentation I have here is a little bit too long for 20 minutes, so I'll go through some of these very quickly. If I were to ask you which county uses the most groundwater in the state, would anybody hazard a guess?
I think Montgomery, just by the numbers.
Well, that's a good guess. All right, but they get most of their water out of the Potomac River. The answer is Anne Arundel County. Anne Arundel County uses about 1/3 of the state's water, groundwater. Right? You start adding Charles, which is a far second, you're getting into about 9% of the state's water. All of southern Maryland adds up to, PG County and southern Maryland add up to about 50%. Fastest growing rate of water use is agriculture. 85% of all of the well applications over 10,000 gallons per day in 2013 were for agriculture. Problem with agriculture is they use 26% of the state's water, but they take it out of the ground in 3 months. So the main concepts I want you to take away from what I have to say: the aquifers, the wellhead pressure. You cannot think of the level in the well as being indicative of how much water is in the ground. It only tells you how much pressure there is in the aquifer. If the pressure in the aquifer were to drop to 20% of its pre-pumping level, then the state is required by COMAR to shut off all applications of water. And one of the things I want to go over quickly is the story of the Aquia aquifer, which is about a hair's breadth away from its management level. Population, obviously we're not going to run out of water. And what everybody knows is that if the water quality goes down, the deeper you drill your well, the poorer the quality of water. You're self-taxing yourself if you want to look at it that way, because you've got the expense of drilling the well, you've got the expense of carrying the cost of treating your own water. And in many cases, that's significantly higher than what the public water supplies have to pay. Our interest, we always get traction when there's a drought, all right? And unfortunately, in 2008, when the major study was accomplished, financial things went south, and basically everything has been kind of, let's say, below the water table at the moment. But anybody here who remembers 1998 to 2002, 4 years, dry years, almost all the reservoirs in the state dried up. That's a Pretty Boy Reservoir in Baltimore, but you could pick any reservoir in the state And we were just within months without water in 2002. This is the study that was done. It was called the Wallman Report. And this was a result of the 2002 drought. When it was completed in 2008, there basically are three things that came out of that report. Basically, we don't know enough about the dynamics of the water in the ground. So the science and understanding the data that we need to understand really what's happening with the water, we don't have that. Second thing is that now that it's been flying below the radar for so long, there's not enough staff resources at the state level and in many counties to be working on this subject. Charles County knows they have a problem. They've assigned 4 or 5 people just to work on this problem of how to handle their water resources. As 2040 for them is basically when you think about the planning and infrastructure that has to be put in place. The aquifers don't go by county boundaries, and we could spend a whole morning talking about really what really needs to happen. It looks like, you know, we need to have more regional planning in terms of water. As I said, Washington County, Frederick, and Carroll County, although they haven't gotten together as a body, they recognize that they have regional issues. Oops, let me go back.
Yeah, there's no.
All right, I think I'll skip this in a bit. We're going to be talking more about what's happens east of the Piedmont, which are called the coastal plain aquifers. West of the Piedmont is the fractured rock areas. All of those areas depend on rain. East of the Piedmont, where we are, it's not rain. The water's in the ground, and you know, the top aquifers, the water is tens of thousands of years old. You go deeper, and you get hundreds of thousands of years old. Go to the bottom, and you're going to get millions of years old water. You aren't going to replace that water overnight with rain. We talked a little bit about that. Just briefly, what is the aquifer? If you think about it, it's basically layers of water, a clay layer, water, clay layer, and then on top is what's called the surficial aquifer, which is where rainwater and everything goes. So those aquifers end in the Atlantic Ocean. So when you pull them up and they come up to the surface, they tip up so that the oldest recharge area where water could get into the aquifer is lying close to the Piedmont, the fall line. And each of the younger aquifers extend further out.
Excuse me. Those layers of water are not just water, it's sand and gravel saturated water.
Yeah, I didn't want to go into
Well, that's important because there's a lot of misconception. People think there's a hollow space under the ground.
No, you're exactly right. And there are a lot of technical discussions that we can go into, but I didn't want to take too much time on it. I'll be glad to go into as much detail as anybody wants to. But you're absolutely right. The surprising thing is that in the sand and gravel, the porosity is only about 20%. So in that layer, you can only think of it as a 20% of it. Some of these layers are only 50 feet thick, so there's only 10 feet of water down there. Some of them are 200 feet thick. I've mentioned this. I'm not going to spend any time on it, but I've sort of mentioned the idea that when the pressure in the aquifer drops, it's written into the code, all right, that MDE has to shut off applications. Basically what happens is that the water enters the aquifer at the fall line, which is much higher than the sea level. So it's the water pressure coming from high up that's pushing down through the aquifer, so that when you put a pipe or a well into that aquifer, the water wants to rise up to the level, all right, in which is called the head pressure, which is at the level of where the recharge area is. The fact that the level is declining means two things. You're either pumping it out of the ground too fast, or the water is not recharging. So two things, and that's what's not understood about how aquifers behave. You might have seen this little thing in the Washington Post last June, talking about world aquifers in distress. Turns out the mid one, number 18, is basically ours. Of all the world's aquifers, we're sort of in the mid-level of the worst of the worst, so to speak. This little graph, and if you'll notice the date, I have it in there. I pulled this data off the web last night just to show you. You were probably going to look at California and want to know why California isn't all red. Well, the majority of their water comes out of the mountains as surface water. The red dots are down there in San Diego where they get groundwater. You can see where in mid there in Nebraska where they grow corn, and all the corn is grown basically by irrigation. Look at that state. That state is in real trouble because they've lost something like 600 feet of water out of the Oglala aquifer. But look at that East Coast. That is a surprise, all right? You're looking at all basically right there from Virginia Beach all the way up to New Hampshire and Maine. That whole East Coast is depending on that aquifer. And those little red and orange dots are all the data that has ever been taken in these USGS monitoring wells, right? This shows you that the data is below the 25th percentile for all time. So let's take a look at Maryland. Look at what that blows up in Maryland, all right? Obvious to us where we're sitting, right? It is Southern Maryland that is the issue here. I want to talk a quick one about what I call the Aquia, which I call it a regional story because it kind of captures, all right, everything that you can describe about what would happen with an aquifer as the population increases. If you look on the left side, that's called the Wason's Corner well, and I don't know if the Wason's Corner is in the southwest corner of Anne Arundel County. And if you look at that, there you see up until about this is about 1970, and all of a sudden you see development taking off. This is the population increasing, and all of a sudden there's this sharp turn of events here. Something happened here. What happened here from Wason's Corner, if you draw a line from Wason's Corner up to the Road River up here, the water pressure is at that level where MDE is concerned about it. If it drops below that level, then Calvert County, Anne Arundel County goes first because that's where the pressure is going to drop fastest. And Calvert, and of course you guys down here in St. Mary's, going to kind of go last. All right, so what do we got? NavAir moved here, Lexington Park takes off, development takes off down here, and so what happened here? All right. Well, here's what's happening. This tells you, this is called the cone of depression. When you take a well and you pump it, the water can't flow back fast enough to it. So it drops the pressure near it, so it creates a cone. All right, you can think of it as a cone of water if you want to think about it that way. And to visualize it, think of when you were kids, you drank a big thick milkshake and it hung on the sides of the glass and made a cone in the milkshake. And what you see in those 2 points here is that the problem here is at Pax River. So this right here, this particular graph doesn't show the latest one, but here this cone of depression is pretty close, like to 150 feet below sea level. Right. So one thing, the way you think about it, if you think about your milkshake analogy, the water's coming down from all sides. Naturally, the recharge area is up here in Anne Arundel County. This is where the Aquia starts. All right, comes to the surface up here, and the water is flowing basically south-east. But when you think of this cone, there's now evidence, all right, that water is starting to come in through the Aquia up through Virginia Beach, which means the pressure has dropped in the aquifer. Virginia Beach is another issue. All right, they've got serious problems down there. They're getting subsidence level. The land is actually sinking to the fact that they pump so much groundwater out and to the fact that sea level rise is rising fast, they have a very, very serious problem. This other area is Waldorf over here. So that's again, another population center. So I just kind of pointed those out. I did a quick back of the envelope calculation. This is not science. I just took the population of Calvert County, looked at its increase, and plotted it against the decline of the water level in Calvert County, and the two lines lined up. That's not a big surprise, obviously. They should, if the people are the people using the water, that's the way it should look, but I just wanted to put that to you. But remember that break that happened in the Aquia. Well, what happened is the people switched to the Magathie. All right, and when they switched to the Magathie, of course, that's what saved, all right, Anne Arundel County and the rest of Calvert County. Why did people switch to the Magathie? Anybody have an idea why?
Who switched to Magathie?
Pardon?
Who switched to the Magathie?
This whole area did.
No, they did not. They switched to Pasco.
No, most of the ones went to the Magathie.
No, I
Well,
disagree with you.
Well, we
I
can
used to
listen.
manage the Water and Sewer Authority in St. Mary's County.
All right, yes,
And
oh,
we
I'm
switched
sorry,
to the
for you,
Pasco,
yes,
Not
yes.
to Magathie.
I think
It
you said
doesn't-
Anne Arundel County. You switched.
It doesn't exist in St. Mary's County or in Calvert, except the very northern part of Calvert. That's
Well,
why
we-
we switched to Pasco.
Well, they told me I'm sorry, I'll go back and check that.
Okay,
All right,
appreciate
no
it.
problem. But anyway, here's the abrupt change, all right? What happened was they found arsenic. And the major users then were asked to switch, all right, basically in 2000, roughly in the late mid-90s, 1990s, to switch out of the Aquia. So what happened here is what I'm talking about in terms of the Aquia, all right, is here we have a rapid use of the Aquia. Had it not been for the need to shift because of actually finding out that they had a water problem in the Aquia, that's actually what saved the current owners of the wells in the Aquia in Calvert and Anne Arundel County. That's just a graph to show you where we're almost in the Aquia, where there are regions of high arsenic. Throughout the state, there are regions of chrome, radon, radium. So there are many regions within the state for which water is not, you just can't drill into the ground and pull water out of the ground. The EPA goal is 0 micrograms per liter. At the moment, they allow 5 micrograms per liter. In Calvert County, what they have to do is dilute the water, all right, with fresher water, all right, to get the right level to be below the maximum contaminant level. Well, briefly about climate change. Don't read the box. I know you can't read it. All the box says is that the scientists don't know how to predict what will happen, all right, with respect to groundwater as the area becomes warmer. It's predicted that we'll have 60 additional degrees over 90 degrees, which basically means that we'll probably have the climate of Savannah and South by 2050. And when you look at where that's happening, the fastest growing temperatures in the region are right here, upper southern Maryland and lower southern Maryland. And the only thing we know is that when the temperatures go up, people use more water. Air conditioners in large, or depending on what type of air conditioners they have, they use more water. Cooling, anything that uses cooling uses more water. Farmers will use more water because of evaporation, etc. So the real problem is how are we going to have a sustainable supply of water? All right? We need to have reliable assessments. Right? the moment, we really don't know if our aquifers are actually being recharged. Because when you look at where those recharge areas are, if you took the Aquia, almost all of the area is in a high intense development in northern Anne Arundel County. Some of those parts of Anne Arundel County are approaching 30% impervious surface. Whenever you disturb the superficial aquifer, all right, you disturb the water path that goes to the recharge of the deeper aquifers. We don't understand how water gets from the surface, gets back into it. We don't know what the specifics of what the insides of the aquifer looks like. You know, as we said before, it's sand and gravel, but within that sand and gravel there may be huge clay lenses. We really don't know exactly what an individual aquifer looks like. I mean, it's literally like poking into, you know, feeling the elephant in the dark room. They drill test wells everywhere to get an idea of what it looks like. But that's one of the issues, is that the MGS does not feel that they have a sufficient number of wells, all right, to characterize the aquifers. We've talked a little bit about that. I'm going to go over that. As again, planners really need to have a really much better insight, all right, into where the water is. And this one here, research is critical. And if you, this is right off the MGS website. It says, note, this study is currently on hold as a lack of funding. Basically, the main takeaway that you should take away. Oops, let's go back through this. Become aware, become involved, talk to your legislators about the fact that we really need to have better understanding of our water resources. We need to look at, perhaps looking at regional uses of water, how we use it. The problem is that we do 10-year planning with GD within our general development plans. Right? The example I gave you in Charles County is they're worrying about the next general development plans, whether or not they have water there. Right? So that really is the issue. The issue is that if we don't understand the recharge, and if we don't understand what's in it, all of a sudden the water could reach a nonlinear use, and the water levels could start dropping much faster, all right, than they are right now. All right. Generally speaking, almost every well, the monitoring well within the state and within the top aquifers are in a constant decline, about 2 to 4 feet a year. A lot of these wells have a lot of drawdown, all right, and at the current usage, the current population, one doing a linear extrapolation says, well, we've got maybe 100 to 200 years, but that's not going to help Charles County, right? Because they're projecting a 50% increase in population. That's where the pressure comes in. If things were to remain the status quo, all right, we got a lot of cushion. Depends on how you project growth to be within the county, how it will impact you. Thank you, and hopefully I didn't run over too long.